Welcome to my new calculus channel. My name is John Gabriel, and in this particular video, which is called ZFC Axioms Belief 4, I debunk the misnotion that there is a fourth axiom, which is in fact the sum, or the axiom of sum, or the sum of union. It doesn't matter what you call it, it's nonsense, and I'm going to be talking about it now. Let's begin. So, the belief of the sum set states that for any x, and x can be an element or a set, we don't know what the difference is between an element and a set because there is no definition of set yet, or element. In fact, we haven't even gotten through belief 4 to be able to confirm that our object is a set yet. And we've already failed on every single so-called axiom. So for any x, there exists a set y such that it's equal to the union of x. In other words, the union of all the elements of x. Well, remember once again that the elements of x can be sets or subsets. So this is called the belief of union, and it's written as follows. It's kind of highfalutin here because, for all x, there exists a y such that for all u, u in y is equivalent to the fact that a z exists such that z is in x and u is in z. And of course, here you've got a lot of interchanging of sets and elements. It doesn't really matter because it's a bunch of baloney. So according to this belief, we can define sets as follows: x1 as 1, x2 as 1, 2, and so on. So you'll notice here that these are the so-called natural numbers up to n, right? Now this implies that the union of all these sets should be the set of natural numbers. Yes? There's no reason to deny that. Okay, so we have to accept that that union must be the set of natural numbers. If we now start removing all the elements from each set of xi, beginning with x1, then all of those sets that you see here become empty sets, right? So x1 becomes empty, x2, all the way up to xn, etc. And this implies that the union of the empty sets is equal to the set of natural numbers because we cannot find the last xi. Isn't that correct? Of course. So the union of xi is equal to n, and the union of the empty sets is equal to n, which means that xi must equal to the empty set. And that's nonsense because the xi's, before the elements are removed, are not empty sets. So this, by the way, is not my proof. It belongs to Professor Wolfgang Muckenheim, who teaches at the University of Augsburg. And so this is proof credited to him. He has also been debunking set theory for the last, 30 or 15 years. I'm not too sure. It doesn't matter. So this is what happens when one uses ill-formed concepts such as infinity or the empty set. And so it's easy to break every single one of these so-called axioms. They're not axioms, they're nonsense. What this proves to you is that there is no such set as the infinite set or a set of natural numbers. Okay? In other words, while there are natural numbers, there is no last one, and it makes no sense to talk about an infinite set. So join me again in the next video to see how belief 5 bites the dust. And that's a pretty short one. It's easy to debunk that one. So we'll see how to do it in the next video. Thanks for joining me. This is the new Calculus channel, and I'm John Gabriel. Till next time, goodbye.